Hello students. So this is the third lecture or PYQ lecture for arithmetic, and today we shall complete all the PYQs from arithmetic chapter. And these are different topics, like some topics like remainder, some topics like comparison of power or relative size of numbers as we call it, and some other topics like series. These are covered. Of course, sequence and series chapter is different, but from arithmetic perspective, whatever questions were there, those are covered in today's session, and we shall eventually cover all the PYQs. If you like this series, then you can ask for it. For today, our agenda is completing arithmetic. So far we have covered around 50 questions, and I think today there are 10 questions, so total there would be 60 questions from last 5 years of arithmetic would be covered. These are directly questions from arithmetic. There are many indirect questions that we can cover when we eventually, I mean, whenever there are other chapters from which the questions are asked, but arithmetic concepts are used there. Such questions can be dealt under that particular headings. Now let's look at this first question. Question is of remainders. We are asked to find out what is the remainder if this particular number 2 raised to 192 is divided by 6. Now this number 2 raised to 192 is a huge number. Okay, it is a huge number, and you cannot possibly compute this actual division by manual division, I mean long division process. So this is a question where it should indicate to you that no examiner in their right mind can ask you to do this manually. So there has to be some pattern that would be forming here. And how do we understand what kind of pattern? You take first few values and pattern would be apparent to you. Now let us take first few values. We have to take here powers of 2. Okay, so let us take 2 raised to, let us start with 1. 2 raised to 1 is 2. What is the remainder? When we divide by 6, 2. 6 into 0 plus 2. 2 square is equal to 4. What is the remainder? 4, because these numbers are still less than 6. 2 cube is equal to 8. What is the remainder? 2. 2 raised to 4, it is equal to 16. What is the remainder? 6 into 2, 12 plus 4. So remainder is 4. 2 raised to 5, it is 32. Remainder 2, and so on. Can you see? 2, 4, 2, 4, 2, 4, and so on. Basically, when we divide 2 raised to odd power by 6, remainder is 2. And when we divide 2 raised to even power by 6, remainder is 4. All we need to see is if this is odd or even. 2 raised to 192. So 192 is clearly even number. So remainder is 4. This question was as simple as this. We just have to understand what is the pattern. And whenever there is a question which seems overtly complicated and impossible to solve in examination hall, there would be some pattern that would be forming. Like here, the pattern was, the remainder was 2, 4, 2, 4, 2, 4. So for even powers, remainder was 4. This is this year's question 2023. Let us see next question. Okay, a number n found by writing 9 for 99 times. Again, this is the indication that some pattern would be forming here. कोई ना कोई pattern तो बन रहा होगा. They cannot ask such a big thing otherwise in examination hall for manual calculation. Now we are writing 9 99 times, and question is what is the remainder if n is divided by 13. N is something like this, 9 9 9 9 9 9, like this. Total 99 times, and we want to find remainder when we divide this by 13. Now again, manual calculation is not possible, so we have to see what are the remainders when we divide by 13. Is there some pattern forming or not? Let us start by 9. We are only writing once. What is the remainder? Remainder is 9 because 9 is less than 13. Then 9 into 9, sorry, 9 written 2 times. What is the remainder? 13 into 7 is 91 plus 8. Okay, 9. We have to perform long division here. So what is the long division? If you are uncomfortable, you can perform long division like this. 11. Fine. One more 9, let us see. 19999. So here one more 9. So here would be 9. 117. Remainder is 2. So far we are not seeing any pattern, but let us not lose hope. Let us see. One more 9. So we have 9 here, 2 here, minus 3. So we have, sorry, minus 26. So this would be, remainder is 3. Fine. Let us try it one more time before giving up. One more 9. So there is 9. 13. 3s are 39. Remainder is 0. Now when we divide this number 999999, so 9 6 times, you get remainder 0. Fine. That is good information. So if I write one more 9, we are starting from here again. One more 9, we are here. One more 9 here. So writing 9 6 times, we get remainder 0. Same thing, writing 9 12 times, we get remainder 0. 18 times 0. So when we are writing 9 in multiples of 6, we are getting remainder 0. If we write 9 96 times, we get remainder 0, because 6 into 16 is 19. So 96 is divisible by 6. So only thing now remains is 999. Right? This is 96 times and this is 3 times, because here we are writing n for 99 times. So till here we are having remainder as 0. We take next 9, we get 0. We take next 9, then 91 and 8 9. This is 78. So remainder is 11. For these last 3 digit, I performed direct long division for 999, which we have performed here as well. Here as well we have got remainder as this 11. Fine. So answer is 11. The pattern was forming that after 6 9s we are getting remainder 0. So after 12 9s also we will get 0. After 18 9s we will also get 0. And so after 96 9s also we will get 0. So only last 3 9s remain. And here you can definitely perform long division for last 3 9s. Okay, this question, let us look at this particular question. Again, question is, which of these given numbers is the smallest? Looks very daunting, but let us see if we can solve it. Now first observe this. This is 2, this is 4, this is 8. All of these are powers of 2, this 4 and 8. So let us first write it. This is 2 raised to 40, this is 2 raised to 21, this is 2 raised to 2 raised to 18, and this is 2 raised to 3 raised to 12. Right? What is this? This is 2 raised to 40, 3 raised to 21, this is 2 raised to 36, and this is also 2 raised to 36. Question is, which is smallest? So because we have 2 raised to 36 here, this is definitely not smallest. 2 raised to 36 is smaller than 2 raised to 40. So one we have eliminated. And again, even if you don't want to actually perform any more calculations, you can see that because both these numbers are same and there cannot be 2 answers for one question, this has to be the answer. That is logically you can conclude, and this is indeed the answer. But if you don't want to go by that, if you want to just compare between these 2 numbers, which of them is smaller, what we can do is, we can see that 3 raised to 3 is smaller than 2 raised to 5. Right? This is 27, this is 32. 27 is smaller than 32. And then we'll take 7th power of both the sides. This sign won't change because we are taking 7th power of both the sides. So we are having 3 raised to 21 is less than 2 raised to 35, which is less than 2 raised to 36. So 3 raised to 21 is less than 2 raised to 36. That is also how we can see this, but logically also we can see that because these are same numbers and there cannot be two answers for one particular question, this has to be the answer. But this is also something we can do. This is a very regulation questions. We had actually done these kinds of question in our class, that whenever we want to show something, some power is lesser than other, or some power is bigger than other, we take some power which are close enough and then take same power of both the sides to prove the result that we want. Okay. Okay, next question, let us look at this. How many pairs of natural numbers are there such that difference of whose square is 63? Fine. We want to firstly find pairs of natural numbers such that difference of those squares of those two numbers is 63. So if we have, let us say, A and B, then we want A square minus B square is equal to 63. Fine. That is A minus B into A plus B is equal to 63. Okay. Now let us write 63 as 63 ka prime factorization we want to write. We write 3 into 3 into 7. This is the prime factorization of 63. Now what we want is, we want to divide this 3 into 3 into 7 into two groups, like one of them is A plus B, one of them is A minus B, and both A and B should be natural numbers. So how many ways are there to do it? Let us see. Firstly, we can write this as 1 as well. Okay. So firstly we can take 1 and 63. That is one way. This is 1, this is 63. This is 1, this is 63. Second is this and this. So this is 3, this is 21. Another way, is there any other way? Yes, 1 is 7, 1 is 9. This quantity is bigger than this, that is given. Okay. Other way, because A plus B has to be greater than A minus B, because these both are natural numbers. Is there any other possibility? No, right? No. So only 3 possibilities. We just have to ensure that we are getting natural numbers in all these 3 cases. So if A minus B is 1 and A plus B is 63, we can add them. So 2A is equal to 64, which implies A is equal to 32 and then B is equal to 31. That is one answer. A minus B is 1, na? So this is one answer, right? So both are natural numbers, so this is allowed. This, let us see, A minus B is 3, A plus B is 21. Again we add, we get 2A is equal to 24, A is equal to 12. So B, from here we can get B as 9. This is another answer which is also acceptable. And third, A minus B is 7, A plus B is 9. Again we add, we get 2A is equal to 16, A is equal to 8, and therefore B is equal to 1. This is also acceptable answer. So answer is 3. I hope you understand. Even if you don't want to perform these later calculations, from this only you can comment that there would be 3 possibilities. Next question, a very easy question, very easy. All that we have to comment is which of these is largest natural number. Okay, firstly it has to be a natural number and then it has to be largest. So what do? We just compare. Firstly we compare P and Q, then whatever is larger of them we compare that with R, whatever is larger we compare that with S. Let us see. So P minus 2000, P minus 2016 is equal to Q plus 2017. So we take this on this side, P minus Q is equal to 2016 plus 2017, which is greater than 0 obviously. So P is greater than Q, that we know. So Q is eliminated. Then we can see P minus 2016 is equal to R minus 2018. So we can take 2018 on that side. So we get 2 is equal to R minus P, which is greater than 0. So R is greater than P. Okay. And finally, we have to then compare R and S because P is smaller than R now. R minus 2018 is equal to S plus 2019. So we can take 2018 on that side, S on that side. R minus S is equal to 2018 plus 2019, which is greater than 0. So R is greater than S. Ultimately, R is biggest. Now let us look at this particular question. A very standard question which we have already done in for powers of 2, but this question is asked in some different language. See, we have to find out what is the remainder when we divide this particular number by 10. Now the thing you have to take a note of is, when we divide any number by 10, what is the remainder? For example, 1 2 3 4, if we divide this number by 10, what would we have? This is 10 into 1 2 3 plus 4, or before that if I write it, it is 1 2 3 0 plus 4, right? So this is divisible by 10, so remainder is 4. Let us take another number, 111 is equal to 110 plus 1, this is divisible by 10, so remainder is 1. Take any number, 1 2 3 4 7 9 8 6, anything. What is this? This is equal to this plus 6, so 6 is the remainder. This number is divisible by 10. So whenever we divide any number by 10, whatever digit we have at the units place is the remainder, right? When we divide any number by 10, digit at the units place is the remainder. So the question indirectly is asking us to find out what is the digit at units place. We have done this kind of question for power of 2, now we will do for power of 3. There is no change, same thing. No examiner in their right mind would ask you to compute it manually. So there has to be some pattern. How do we see pattern? We start with initial few powers. So let us see 3 raised to 1. What is the units place? 3. 3 square, units place is 9. 3 cube is 27, units place is 7. 3 raised to 4 is 81, units place is 1. 3 raised to 5 is 243, units place is 3. Now we will see that everything will repeat. 3971 and so on. 3971, 3971 will repeat. And why does it repeat? Because we are doing nothing but multiplying by 3 every time. We are taking powers. What are powers? Powers are repeated multiplications. We just multiply 3 by 3, you get 9. And digit at units place would be only influenced by whatever we have at the units place only. Whatever we have in other places, other places is irrelevant. So here 3 into 7, 1. 3 into 1, 3. 3 into 3, 9. 3 into 9, 7. So only units place matters, nothing else. So we have this kind of pattern. So powers of 3 repeat in the blocks of 4. So to find out about this particular thing, we have to just comment on where does this 2019 lie in these blocks of 4. Basically we have to divide 2019 by 4 and comment on what is the remainder. We know that 2016 is divisible by 4 because last 2 digits, that is the divisibility test of 4, and plus 3. So remainder is 3. When the remainder is 3, what is units place? 7. That is the answer. Units place is 7 means this number is something like something, and at the end we have 7. So whenever we divide this particular number by 10, you get this plus 7. So the remainder is 7. I hope it is clear. Again, this is the question I was talking about. that almost always this kind of multiplication and when divided by 100 or 10 or any other number, 90% of the times answer is 0, but this is those 10% where answer is not 0, because 0 is not even in the options. Question is what is the remainder when this particular quantity is divided by 100? Okay, fine. What do we do? What is the gut feeling? Let us first try to write this as a product of prime numbers. Let us see how many times 2 appears and how many times 5 appear here. So 2 is clearly appearing only once, right? 2 is clearly appearing only once, and 5 is appearing twice here and once here. And then there are some other factors. That is okay. Let us worry about that later. So this is nothing but 10 into 5 square into something something. So whatever this particular number is, it is having 0 at units place. Okay, fine. And 25 is also a factor. 5 square is there, no? So 25, 5 square is 25. So number is multiple of 25 and it has 0 at the end. 1 0, not 2 zeros. That is for sure. So let us see what kind of multiples of does 25 have. 25, 50, then we have 75, then we have 100, then we have 125, then we have 150, then we have 175, then we have 200, then we have 225, then we have 250, and you can see that these are the multiples of 25. So whenever we have factor as 25, look at the last 2 digits of multiples of 25. 25, 50, 75, 00, 25, 50, 75, 00, 25, 50, 75, 00, and so on. So these are the multiples of 25. So any multiple of 25 has to have one of these 4s at the units place, at the units and tens place, last 2 places. And for this particular number, we have 0 at the end. So these 2 are not possible. Of course, is this possible? No, because there is only 1 0. Only once 10 can appear. 10 cannot appear more than once. So it has to have 50 at the end, last 2 places, right? So this number is nothing but some ... and end may 50. Now again I want to emphasize on this, that what is the remainder when we divide any number by 100. We saw something for 10, now we'll see for 100. So whenever we divide number by 100, this 1 2 3 4 5 6 divided by 100, can we write this number as 1 2 3 0 0 plus 56? What is the remainder? Remainder is, whenever we divide this number, any dividend by this number 100 into some quotient plus remainder. And what is the condition? This remainder has to be less than 100, has to be less than quotient. That is the only thing. That is, this remainder has to be less than 100. So remainder is a single digit or 2 digit number. So last 2 digits, this number is divisible by 100 always, because we are writing 0 0 at the end, and then whatever remains, last 2 digits would be the remainder. So whenever we divide any number by 100, last 2 digits is the remainder. That is what we are saying. Whenever we divide any number by 10, last digit is the remainder. Whenever we divide number by 100, last 2 digits are the remainder. So what are last 2 digits for this particular product? We found out 50. So answer is A. Next question, let us see. In a race, a competitor has to collect 6 apples which are kept in a straight line on a track, and a bucket is placed at the beginning of the track, which is the starting point. So this is a track. Here there is a bucket placed and competitor has to collect 6 apples. Okay, condition is that the competitor can pick only 1 apple at a time, run back with it and drop it in the bucket. Okay, competitor has to go collect apple, only 1 apple at a time, come back, drop it in a bucket at the start line, again go, again bring back 1 apple, and so on. And here competition, he has to collect 6 apples. If he has to drop all the apples in the bucket, how much total distance he has to run? If the bucket is 5 meters from the first apple, this is 5, this is here there is first apple, and all the other apples are placed at 3 meter apart. So here there are 3, 3, 3, 3, and this is also 3. These are the 6 apples. Okay. So he has to go 5, bring first, come 5. Go 5 plus 3, come 5 plus 3. Go 5 plus 3 plus 3, come 5 plus 3 plus 3. Basically, this is kind of, this is what we call as arithmetic progression. There are 2 ways to do this. One, you can just manually calculate that kitna hoga, 5 plus 5, 5 plus 5, फिर 5 plus 3, 8. So 8 plus 8, then plus 3, 11 plus 11, then 14 plus 14, then 17 plus 17 plus 20 plus 20. कितने apples हुए? Yes, 6 apples are done. Is there some mistake? Right? Yes. So this is the total distance is traveled. Just add them or you will have your answer. This is 10 plus 16 plus 22 plus 28 plus 34 plus 40. Add them. What do we have? 6 to 8 and it's 16. 16 plus 4, 20. 20. Carry forward 2, 4, 8, 4, 6, 8, 3, 11 and 4, 11 and 4, 15. Answer is 150 meters. Other way is that you put everything in the formula for addition of AP and double it, because person is going ahead and coming back. That we'll see in class, so that if some of you want to look for formulas and mug them up, you can do that as well, but it really is not needed. There are just few additions that needed to be done and you are through. Next question. If the numerator and denominator of a proper fraction are increased by the same amount, same positive quantity which is greater than 0, the resulting fraction is. Now it is a very simple question, and again there are 2 ways to do it. There is more formal way to do it, or you can simply do it by putting values. Both are equally fine. I don't have any issues with any of the methods. Now firstly you just have to know what is the proper fraction. Proper fraction is a fraction where there are no common divisors from numerator and denominator, that is all. So something like 2 by 3. Let us take 2 by 3 only. Now we are adding some positive quantity greater than 0 to the numerator and denominator. Let us add 1. So let us see, this is 3 by 4, add in 1. Now we just have to decide which of them is bigger or which of them is smaller, or the quantities are same. How do we see that? We just cross multiply. 4 into 2, 8, 3 into 3, 9. So this is bigger, cross multiplication. So this is 1, that it is coming out bigger. Okay, fine, that could be one conclusion. Let us take some other values. For example, 1 by 7 and add some quantity, let us say 8 to it, 9 by 15, we are adding 1. Now let us decide, this is 15, this is 63, again this is coming out as greater than. Okay, clearly there is high possibility that this new quantity is greater than old quantity. Fine. Now let us take one last example and then we can be sure. What do we say? We take let us say 4 by 9, okay, and then we add some quantity, positive quantity 10, let us add. We get 14 by 19. 19 into 4, 76. This is 126. Again this is bigger. So this should be the answer. If you want to look at it more formally, we can take a by b. New fraction would be a plus k by b plus k, multiply a into b plus k, and here we have a plus k into b. This is ab plus ak, and here we have ab plus bk. ab would be cancelled and kk would be cancelled. Then we have a and b. Because b is greater than a, this is always greater, because this is a proper fraction, so denominator is greater than numerator. Okay. This is the last question. Again, very easy question. Question is, which of the following will have minimum change in its value if 5 is added to both numerator and denominator of the fractions? Now simplest thing to do is just add and check. Minimum change is, let us calculate change and we'll have minimum change. Last question. Okay, so we have 2 by 3. The new fraction is, we add 5, 7 by 8. We have 3 by 4. New fraction is 8 by 9. We have 4 by 5. New fraction is 9 by 10. And we have 5 by 6. New fraction is 10 by 11, right? To find out which change is minimum, we have to calculate change. Change is this minus this. Change is equal to 7 by 8 minus 2 by 3. I am sure you guys are familiar with how to subtract two fractions. So we can see that cross multiplication, 5 by 24. This is 8 by 9 minus 3 by 4, which is equal to 5 by 36. Here we have 9 by 10 minus 4 by 5, which is 5 by 50. And here we have 10 by 11 minus 5 by 6, which is 5 by 66. When the numerator is same, the value having highest denominator, the fraction having highest denominator is the smallest. So this is the smallest fraction of them all. So this is the smallest change. So answer is 5 by 6. Right? That is all. I hope arithmetic was clear for you. Of course, here there are limitations for me, that we have time limits as well. But if you are interested in solving these PYQs in much more detail and to learn how to really handle questions without going much into formulas or anything like that, do come and join our course. It is starting from 20th of October. You can come for first few lectures as demo lectures. No issues in that. We can again ask any doubts. You can ask any doubts you have in the comment section, or come to meet us, and we'll continue this series tomorrow. Thank you.